Hi Sangram, thanks for joining. So this is my teammates,
Hey,
and
Mamta.
yeah,
Hey
thanks for
Sangram, hi.
Hello,
taking
Sujit.
time.
Hey, Akansha.
Hi, Sangram.
So we'll just wait for a couple of seconds, maybe like other teammates might join, and then
Mm-hmm.
we can make a start.
Sure.
Um, so how about our video? Like, do we have to share our video also or not?
Yep, I think I'll make a recording. Yeah.
Okay, let me.
So let me start with his introduction. So he's Sangram, like he's been working with as a big data engineer for over 10 plus years of experience. Currently, he's working in Walmart as a big data engineer. So yeah, uh,
Oh, nice to meet you, Sangram.
Nice to meet you all.
I hope this conversation will be very insightful.
I'll try to give as much information I have. Well, tell me something about yourself, like how California has been treating you, how San Jose University has been treating you.
It's good. Like our course is not so good, but San Jose is good.
San Jose is good. Okay, nice.
maybe let's make a start. Let's just hear from you about your experience and role as a big data engineer.
Well,
Guys, are we? I'm
mhm.
sorry for this. Are we starting? We need the two members before we start.
Okay, I think we're still 2 minutes.
Mm.
Yeah,
They
yeah.
joined.
Okay,
Okay, let's start from the beginning.
yeah, sorry.
Yeah.
We can make a start. Yeah, sorry.
Okay. Okay. Hi, Sri. Hey, Praveen.
Hi, how are you?
Doing good. How you guys doing?
Yeah, we are doing good. We are doing good.
Okay.
Yeah, nice to meet you and talk to you actually.
Sure. Pleasure is all here. Okay, let's get started. Tell me,
So, like maybe just your experience as a big
hmm,
data engineer so far and
so
your journey.
I started my career around in 2012 sometime, and I didn't start as a data engineer. It was mostly a data analyst role, which was mostly SQL heavy, getting requirements clarified, converting it into right requirements. Though I was coding, but at that time, Spark was very new. It was MapReduced. It was not even Spark, I would say. Hive and MapReduce was mostly used. Um, I was working mostly on Oracle and Teradata. Those were very known technologies at that point of time. And slowly I transitioned from analyst to a data engineer role. And that happened like probably 3 years into my career. I got transitioned into data engineer role where I was building, uh, I would say, near real-time pipeline into Vertica using Python. That was my first, like I would consider that as a role where I was writing pipelines. But before that, it was mostly, analyzing data, figuring out if the data is correct or not. Is it garbage in, garbage out? How the data volume would matter. I mean, uh, one advice I would like to give you, since you're very new into this kind of roles or you would get into it, consider data as your first citizen. Without that, I don't think we have an existence. There will be technologies coming in, going out, but what matters is how correct your data is. Like most of the people ask question, hey, what do you do in your day-to-day activities? I would say, I mean, what you do is right. As a student, you read what are the technologies, but once you get into any company where you have to apply those technologies, that would be there, but your first priority should be, am I writing right data? Is my data 100% accurate? Without that, if you're just storing junk value where you don't have confidence on your data yourself, you won't be able to answer the analyst question. You won't be able to answer the data science team questions, or even this teams won't be able to make use of your data. So just keep that in mind when you are building any pipelines right now. Don't just, depend on Kaggle data. Those are mostly, cleansed, pre-processed, where you have, all columns populated, very less nulls. Um, Probably the indexes are correct, but that rarely happens in real world scenario. You will find a lot of nulls in data. You don't know how do I join this three or four tables. Maybe someone tells you, okay, you join on that columns, but then hey, when you join them, you find you're getting skews. Why? Because my lot of my columns are null. But yeah, those are a couple of things probably once you get into any real world example, I think you should implement all those things. But yeah,
Th-
let's.
Thank you. So going forward, based on your experience, like how are the big data topics, like in the course we have studied about Spark, Hadoop, and distributed system. How do we actually use these in industry?
So Spark is backbone, I would say. There are a lot new processing. I mean, you should consider Spark as a processing engine, nothing more than that. There are many other processing engines. You have, it depends like what you are exactly trying to do. If you're trying to process, massive data set and your aim is to, do it at a very cost efficient manner, uh, you should consider Spark. Now, Spark could be on GCP, Spark could be on AWS, but then yes, there are many other technologies. Snowflake is there, which can, do joins for you, which can wrangle data for you. But Spark is, I would say, undisputed champion over there. Um, Hive is one such factor which you should consider because, you know, okay, I'll take a step back. Now, when you store data, you have to understand just storing data that doesn't matter. You have to consider what cost do you pay in storing those data. It's not just about, storing 100 columns, but you have to also consider like, is it petabytes of data? Is it terabytes of data? How much do I pay for storing that data set? Now, in Snowflake, probably it could be much more costlier processing 100 terabytes of data or joining it to, let's say, transaction data, which is of 100 terabytes, and your customer data, which is, let's say, some GBs of data, it would cost you a lot, which Spark might not be that much, it would be cost efficient. So you have to consider those things. I would say Spark is the backbone, and your storage could be SWS, like S3 in AWS. I in Walmart use GCP, so we store data over there. But MapReduce as such is kind of not there as like it was there earlier. The biggest reason being MapReduce used to, write after each step into your storage, which could be S3 or anything, whereas Spark does it in memory. So right now, I would say Spark. For storage, it could be S3 or GCP, and then Kafka. Those three are the undisputed champions.
Thank you.
Yeah, so in our course, we have been pretty much learning about Spark, Hive, and Kafka, like what all you have mentioned right now. But we do not have like so much of practical knowledge. Like we did not use it properly. We are just using it for a assignment. So as you're working in the industry, like what tools do you use actually? Which tools do you use in your current workplace and all?
So, like I was saying, right, Spark, you can use it from anywhere. You can install Spark on your local system. You can act. Spark is kind of a processing engine, right? If you have to process certain amount of data, you have to use Spark. Now, Spark you can run from GCP through Dataproc or through serverless. Same through Amazon. Same through Docker. There are multiple channels which you can do. Uh, it all matters. Like if you are processing, let's say 10 bytes of data or 10 megabytes of data, you can do it on your system, or let's say even 1 GB of data. But scale is all what matters. For that, you need to have a right set of platforms where your Spark is installed. And it's not just about running Spark. You need to have right set of monitoring so that you know if your Spark jobs are running fine because Spark is, I mean, you would know, right? Spark is fault tolerant. If due to certain network issues, it retries and tries to complete your job. But hey, you expected your job to complete in, let's say, 35 minutes, but it went for 2 hours. Cost comes into picture there. Hey, you because you have to pay for 2 hours of the job. So if you have right set of monitoring, you know that okay, my job is now running long, or let's say a couple of my tasks failed. What was the reason? Maybe you could take an action much more faster. Okay.
Yeah. Okay, like how important is Apache Kafka in today's ecosystem, and like where do we use it? Like in what particular practice or practicals we use it? Particular.
Kafka is everywhere. If I say, do I
Apache Spark.
Spark?
Yeah, I was.
Again, it depends, right? Company to company. There would be some company who don't want to, spend a lot of effort on maintaining Spark. Uh, Consider as this, writing and SQL.
Mhm.
If I give you an UI, you are good to join multiple data sets and get your data done. But you don't want to spend a lot of time in building a data lake. Now there are two set of people, right? One is data engineer who join data sets or to build data lakes and who bring data from multiple systems. And there is one sort of people who could be data science or data analyst. Now Spark is mostly usable for data engineers who process a lot of data to make it usable for others. Now, for data analyst, they might not have to do that. They just want to join couple of tables to get certain, analysis done. For them, Spark is not required. Or there is a company who do not have that volume of data and then they don't want to, spend time on setting up that Spark platform. They can simply be on Snowflake. Their
Yeah.
data volume is less. Snowflake gives you 100% monitoring. Everything is available, in one single tool. For those cases, Snowflake is good. But where you have a full-fledged team, you are invested in, maintaining the monitoring, you want your costs to be low, then Spark makes more sense.
Okay. How about storage formats like per question data lakes we use in real world system? Like, what about it can?
So, two things. When you store data, you have to think about two factors. One is storage format and one is table format. Storage
Mhm.
format is basically your ORC, Parquet, CSV, JSON. Now, CSV, JSON, people should not store it in that. It doesn't compress any of your data. If you are storing, let's say, 100 column row and you have, let's say, 1 TB of data, you're storing 1 TB of data in your storage location. Now you pay for 1 TB of data, not just for storing, but every time you access that data, the IO cost you are paying, which is massive.
Mm.
Now, how Parquet and ORC comes into pictures. Now, both of them compresses data. Not only it compresses, it gives you an efficient way of selecting data. For example, out of that 100 columns, for your analysis, you just need 2 columns, right? Now, if it is CSV or JSON, it will load all those 100 columns of 100 or let's say 1 TB into memory, which you will be giving scanning cost, which is basically your IO cost plus getting those data into memory. Whereas if it is just 2 columns, you are basically, spending, let's say 20% of your uh, IO cost. Right, so that is one part of it, and there are multiple cases where do you want to use ORC. Now, if you are an analyst, or let's say you want to expose your data to analyst who wants to use SQLs, then ORC makes more sense. If you want to do most of your processing through Spark, then it makes sense to have your table in Parquet format. Now, it has its own pros and cons, but then either of it would be good. If Spark stick to Parquet, if it is mostly for, let's say, SQL related thing based on Presto or let's say Hive, then ORC makes more sense.
Okay. Thank you.
Akansha, maybe you're on mute.
Yeah.
Yeah, Sangram. So my question is, so as you are saying that initially you used to work with MapReduce, but now it's been replaced by Spark. So mostly you work with Spark now. So are Hadoop and MapReduce still relevant? Like not in your case, but there are other engineers
I
who also.
doubt, I doubt
Mm,
MapReduce would be used anywhere. At least I don't know anywhere it
mm,
is being used. Uh, because think of that situation, right? Now uh, you have to write a code which has, let's say, 20 steps, right? You write 20 sequels to achieve what you need. Now, in terms of MapReduce, every time you read it, before it goes into next step, it actually writes into your
yes,
system.
yeah.
So see how slow it is. And in any failure case, I mean, you can definitely write your checkpoints, but in any failure, it tries to restarts from the beginning. So, I mean, that was the reason like why Spark was developed. And I don't think right now anywhere MapReduce is used. I mean, I can be wrong, but yeah. But MapReduce I haven't seen anywhere being used right
Mhm.
now.
Okay. And another thing is, what are the common challenges that you face while working with large scale data?
Okay, that's a good question. So now you're writing a pipeline. Let's say you are writing a fresh pipeline to, let's say, join a couple of tables and build an aggregate. So when you write that today, you have, let's say, mm, 1 GB of data in each table. You design your pipeline, you assign certain executor, certain driver, you assign certain memory to it. It goes fine for, let's say, 30 days. But then as and when the system grows, your data grows from 1 GB to, let's say, 100 GB, your pipeline fails. Because whatever code you have written, maybe you would have written it for 100 or 1 GB of data, right? So
Okay.
every time we write a pipeline, we have to think, okay, how it will perform 2 years from now, right?
Okay.
Data grows. We have to think about, like I was talking in beginning, you have to think about nulls, you have to think about empty spaces. Though in data it would look as blank to you, but nulls and empty spaces are both different thing. You have to treat them separately. When you join them, you have to handle skews. How do you write into your system? Because probably processing takes is efficient. It takes maybe 2 minutes, but writing your 3 months of data is where you're spending a lot of time. So probably you have to partition it, or probably you have to run your pipeline in months. There are multiple ways of doing it. So those are factors which you have to think while writing or starting fresh. What happens 2 months or 2 years down the line to this pipeline?
All right. That's a news to me. Okay.
Yep.
Uh, so I have a question.
Hmm.
Like we are in our academic curriculum, we are doing our assignments with a particular data set, which is which is of GB or like something, some amount of storage, and we are running it in the local, and you will be dealing with most of the enterprise data warehouse and big data.
Mhm.
So my question is, in your opinion, what are the key differences when it comes to our learning and in your real world big data work?
All right.
Like,
So,
is it sufficient
hmm.
enough to make the trend analysis with the amount of knowledge that we gain from our
Uh,
curriculum?
it 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 will definitely change when you go into any system. Your way of looking into data changes, as you mature as a data engineer, or let's say as an analyst. It just you have to understand how that particular organization is storing data or is trying to make use of data. See, when what you or what even I was doing during academics, I was trying to learn specific language. How do I join tables? What is left join? What is right join? What is left semi join? But as I'm in system, joins matter, definitely. I have that is probably 40% of my job, but my rest 60% of my job is to build a stable application. Now, stability comes into picture when your pipeline doesn't fails, when your pipeline doesn't gives you sudden spike on cost. It could be storage cost, it could be processing cost. Your data is 100% accurate. How do you write your data quality checks? Now, probably in your academic career, you might not have ever thought about data quality checks. Now, data quality checks are something, for example, you have three columns. Now, those three columns constitute your primary key. By definition of primary key, those columns should never be null. So you just write a single line of statement saying, okay, I have loaded, let's say, last 2 days of data into my table. Your table could have, let's say, 100 days of data, but in my last 3 days of data, I should not have any null on those three columns. Similarly, you could have integrity checks. You could have, not null checks. There are multiple checks which you can do, but that's a must. That's where the data monitoring comes into picture, and then you need to have your pipeline monitoring. So, in short, in academics, we learn about the language. In actual world, we try to see how we can apply them, but at a much lower cost, with stability first in mind, and data being first priority.
Okay, so as per you, uh, so stability comes with a stability. What are the metrics for stability? Like you have said that, like, is it cost? Is it
No,
about cost?
so when cost is one part of it, so when I say stability, because let's say you are a team who is maintaining a, let's say, orders data set. Now there is a certain team who is generating from, let's say, there are real-time systems. Every time customers purchase something, an order is generated and multiple columns related to orders are generated. Now they will push that message through Kafka. Now you are a data lake team who stores all these orders, right? Now, when I say stability, few things comes into or should come into every engineer mind, that my data should be as real time as possible, if that's a requirement. Now, real time has its own challenges. When I say challenges, it should always come to your table, let's say within 1 second, or let's say 2 second latency. But you have, let's say, 20 other columns. Is that also available in next 2 seconds? Because probably some other columns would be coming from different systems, right? You get probably order ID or some other columns, but every customer related information probably it is coming from a different system. Your ads data may be probably coming from a different system which is related to the same ads. Do you get it within that 2 seconds, right? So because whoever is using your table, they also rely on you, that whatever SLA you provide, right? So if you say my table would be updated with the latest information that is available in source in next 2 seconds, that means we have to always adhere to that 2 seconds SLA. Otherwise, your data cannot be guaranteed by other teams. They probably won't be able to reliably use your data set to deduce anything. So that is one part of stability. The second part of stability is data quality. Your data should not be garbage in, garbage out. It should be pristine. It should be as clean as possible. Uh, as a practice, when we create new data sets, we define, let's say it has 10 columns, we say, okay, this column means this. Either it can have null or it cannot have null. What are the cases it can have null? So as an engineer or as an owner of the data, we should be 100% aware of what each column means and how the next team should be able to use it. So that calls for stability. Definitely cost, running pipeline at the right time. If you say that, okay, my batch pipeline runs for 30 minutes, it should end before 30 minutes, because now you are, let's say, the first team of for processing this data. You have your downstream, you have two or three more downstream. they
Yeah.
have to again process it, right? So if you tell them 6 a.m. is when my processing will complete, we should adhere to 6 a.m. Otherwise, their pipeline will fail. Those are all stability metrics.
Cool. That's informative. Thank you.
Sure.
Yeah, so before concluding, I have like one last question maybe. So like right now there has been so much speculations or whatever, like rumors, or maybe it is true that AI is taking away all the jobs and everything. So how do you see the future of big data, and like what do you suggest to the people who are taking big data as their like their passion or their job, career, whatever? So what do you suggest?
Well, every 10 years, some new technologies come in, and definitely there is a fear that something will go away. But I think we have to be more straight in adapting to those new technologies. See, at some point of time, I'll say, yeah, AI can do, LLMs can do a lot of things. But hey, if you have the right amount of business knowledge, you know what your data is about to give you, that any AI won't be able to tell you. Probably it can, but it has to spend a lot of resources. You think for yourself, let's say you have 10 years of data, which is petabyte of data. You just give an AI, hey, can you analyze this and tell me what this data is all about? Yes, it can probably do that, but think how much cost it would have to, spend if it has to analyze all those data. So yes, it can write codes, but then there will always be a human loop to verify if that code is correct or not. Probably it can write optimized code, but then the human in loop should verify, is it actually following all of the business logic. So definitely humans would be required, but it will be helpful for engineers. It's not kind of a threat. We should be able to take that as a companion and write better codes rather than thinking it will take our jobs.
Thank you so much for your time on a Sunday evening. Yeah. So I
No
think
problem at all.
that's all from our side.
Yeah.
I think we got very good insight about at least what's going on currently.
Awesome.
Yeah, yeah, that was very
Thank you
informative
so.
actually. Yeah. Thank you.
Thank you so much.
All right,
Thank you
team.
so much.
All the
Thank
best.
you. Thank
Thank you
you.
so much.
Okay. Bye-bye.
Bye.
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 Recording.